Assalamualaikum and hi. My name is Muhammad Polyvinyl model. So for our Polyvinyl project, the title Fabrication and Characterization of Polyvinyl alcohol with Polyacrylonitrile membrane for Pervaporation application. So based on the previous research that we studied, for example, the development of a PVA membranes modified with zirconium-based metal organic framework ZRMOF. Based on the result, the degree of swelling for only PVA membrane with in a water isopropyl H2O obtained was 53%. By adding the unmodified ZRMOF, the degree of swelling value increased into 58%. So based on this result, the degree of swelling is quite high. Actually, this is not good for the pervaporation process. It's minimum. So our aim for this research is for a fabrication and characterization of PVA pen membrane for a better pervaporation process.
Hello, my name is Muhammad Anwar bin Muhammad Rahizat and I am Chemical Engineering Technology student. In this part, I will explain the background of study and objective of our research. First of all, energy plays an important role in various sectors such as manufacturing, health, education, business and other service sectors. The main energy resources come from fossil fuel, which is non-renewable energy exists in this world. For example, natural gas and petrol oil. The emission produced by the combustion of fossil fuel can contribute to the environmental problem. Biofuel derived from microorganisms like bacteria, yeast and algae are a promising alternative to non-renewable energy fuel. The production of biofuel often involves APA fermentation, which is microbial process that produce an organic compound such as acetone, butanol and ethanol. However, APA fermentation can sometimes lead to toxicity issues. Thus, separation process will be conducted regularly to counter this issue. Separation process is essential in a variety of chemical processes, including the removal of impurities from raw materials, removal of contaminants from air and effluents. There are many separation processes used in the industry, but pervaporation is considered an attractive process for the continuous removal of ethanol from fermentation medium. Pervaporation is a membrane separation process that is particularly effective for separating liquid mixture. Pervaporation process involves specialized membrane of materials that are selectively permeable to certain components of the liquid mixture. For our research, polyvinyl alcohol PVA and polyacrylonitrile PAN are two main materials used in the production of a membrane due to their unique properties. The objective of our research is the preparation of PVA PAN membrane through thermal drying method. This research is also to study the characterization of the developed membrane in terms of mechanical, physical and chemical properties.
For the FTIR or Fourier transform is infrared spectroscopy, it was used to identify the functional group in the chemical structure of pristine PVA, pristine pen, and PVA pen membrane. As you can see in the slide, these are the result of the FTIR. For the pristine PVA, it has a OH group, alcohol group at the group peak at 3,200 to 3,550 cm. It also has CH group, and it also has C-O group. For the pristine pen, it has a CH group. It also has C group, alkene at a weak peak at 1,610 to 1,650 cm. It also has CO group. For the PVA pen membrane, it displays the same functional group as the pristine PVA and pristine pen. So based on this result, the presence and intensity of this wave number can provide the important information about the chemical composition and structure of polyacrylonitrile pen and polyvinyl alcohol membranes.
Scanning electron microscopy SEM was assessed to determine cross-section and surface of membrane. By using 20 kV SEM, all membrane samples such as pristine PVA, pristine pen and PVA pen membrane were obtained in this research. All membrane samples were cut into small pieces using liquid nitrogen and analyzed using the SEM instrument. The cross-section and surface of membrane were evaluated in this technique. The sample were coated in thin layer of gold using a sputter coater unit.
Next, based on figure 2 and 3, the developed membrane does not show much difference
In fact, it shows a dense cross-section and a smooth structure without any porosity. It also shows a dense structure with a visible tearing effect. Meanwhile, based on figure 4, the developed membrane shows a porous cross-section and a textured surface. However, this is because PVA has a high OH functional group and it's cured at high temperature, which is make the PVA pen membrane less dense.
The next characterization is degree of swelling. The degree of swelling of the membranes were analyzed to estimate the degree of water permeation into the film. Different solutions were used to compare the capability of each film to resist swelling, which is the membranes were immersed in the distilled water, 5 weight percent ethanol aqua solution, 10 weight percent ethanol aqua solution, and pure ethanol. For the pristine PVA, the sample shows the highest percentage of the swelling degree when being immersed in the distilled water. However, the PVA sample soaked in the pure ethanol show negative value, which is the lowest value recorded in this analysis. As a result, the PVA shows the higher degree of swelling and hydrophilic properties, indicating good water absorption, while the PAN can be determined as the hydrophobic properties that resist to water.
The Newster testing machine was used by following the STM-DA2 method to analyze the mechanical properties of the membranes, such as tensile strength, young modulus, and elongation and break. As we can see in the table, for the pristine pen, it has a high tensile strength, 1913.02 megapascal. It also has a high young modulus, but it has a lower elongation and break at 2.73%. For the pristine PVA, it has a lower tensile strength and has a lower young modulus. While for the elongation and break, it has the highest elongation and break at 86.79. While for the PVA pen membrane, as we can see in the table, it has a high tensile strength at 1831.63 megapascal. While for the young modulus, it has the highest young modulus compared to the pristine pen and pristine PVA at 108,782.05 megapascal. While for the elongation and break, it just a bit higher than the pristine pen at 4.66%. So, by combining the strength and stiffness of the pen with some flexibility for the PVA, it makes this PVA pen membrane have a potential for the pervaporation process.
In this table, it shows an estimation cost of our research to develop membrane. As mentioned before, our group used polyvinyl alcohol (PVA), polyacrylonitrile (PAN), and dimethyl acetamide (DMAT). The estimate cost for the production of the membrane is around 48 ringgit and 95 cents. This cost is considered a reasonable and minimal budget. In addition, all materials used are chemically stable, environmentally friendly, and non-toxic.
For our research contribution to society, firstly, ethanol is a renewable energy source that can reduce the dependence on fossil fuels and contributing to environmental cleanliness. Next, the use of membranes can increase the quality of ethanol with a lower water content, which is essential for transportation fuels and industrial processes. And lastly, the use of pervaporation membranes for ethanol separation can reduce the energy consumption and environmental pollution compared to the traditional distillation method.
So for the conclusion, the aim study to create a hydrophobic membrane using polyvinyl alcohol and polyacrylonitrile for pervaporation. The results show that formulation PVA and pen at 1:1 has potential as a membrane. The functional group present in this membrane were analyzed, showing that hydroxyl, alkene, and carbonyl group were present in this membrane. The morphology analysis show a texture surface with porosity and less dense structure. The swelling index show a balance between hydrophilic and hydrophobic properties. The mechanical properties of the mixture PVA and pen membrane show high tensile strength, high young modulus, and moderate elongation at break. The study provides valuable insight into improving the efficiency of separation process.